All right, Unit 15, Day 2, polar coordinates. This is kind of a unique lesson, a different lesson, different way of thinking about things. Some people kind of enjoy it because it stretches their brain a little bit. Other people just fight it the whole time and can't ever make sense of it. Most of you guys, well, all of you guys are capable of understanding it. We'll just see if you appreciate it or not. What we're used to is rectangular coordinates. We hardly even call them rectangular coordinates because it's the only coordinates we do. The x and y. Right? The x is the left-right coordinate and the y is the up-down coordinate. I mean, like, this is super basic, but we're going to contrast that with polar today. So 3, 4, I mean, I know you know this, but just reminding us how to think about coordinates. So that means 3 in the x direction, 4 in the y direction. 3 in the x, 4 in the y. So there's the point 3, 4 in rectangular coordinates. So that's super basic, you know that, but I guess the big thing is it's not just coordinates anymore. We need to be sure we're talking about, or know whether we're talking about rectangular coordinates or polar coordinates. So rather than an x and a y, a left, right, up, down combination, with polar coordinates, we identify a point with a radius r and an angle theta. So instead of x comma y, it's r comma theta. So it's a different way of getting to a point. The radius is the distance from the origin. And the angle is the rotation from standard position being the positive x-axis. So always rotate from the positive x-axis. All right, so now we'll grab the packet, because we're going to use that second page polar graph paper for practice. Kind of jump back and forth here. I'm going to plot some points. So let's first plot point A, 2 comma pi over 3. So that means r equals 2, theta equals pi over 3. Now, you can use either one first, just like with x and y. You could go y first or x first. It doesn't really matter as long as you're keeping track of what direction you're going. And that's the same thing here, but I think it's usually best to use theta first. And then the radius. And you'll see why in a minute. But for now, let's use the angle first, and then we'll use the radius. So if angle's pi over 3, that means I want to rotate up from 0. So here's standard position, the positive x-axis. I want to rotate pi over 3. So it's nice and labeled. So that puts me on this angle And then radius is 2, means I want to go 2 out from the center. 1, 2. So there's point A. Rotate pi over 3, go out 2. All right, let's do a couple more points, because the negatives get a little tricky here. So let's do -1, comma 5 pi over 6. So don't worry about the negative yet. Let's rotate to 5 pi over 6. So rotate all the way around to 5 pi over 6. So that puts us on this angle. Any thoughts on what -1 would make us do? Yeah, it would make us go backwards. And so we're on 5 pi over 6, but instead of heading out, the negative makes us go backwards. So I grabbed the popsicle stick, because sometimes people, when they go backwards, they end up on the wrong angle. So make sure you're going exactly 180 from the angle you originally landed on. So that would put us right there for point B. Which kind of brings up another point. There's another way to describe point B. Andrew, you almost said it. So if I ask you to describe that point, what angle would you tell me we rotated through? 11 pi over 6. And what radius would that be if we rotated 11 pi over 6? 1, a positive 1. And so this is something that's unique about polar coordinates as opposed to rectangular. In rectangular coordinates, if you're at the point 3, 4, like that's the only way to describe that point, 3, 4. There's no other way to get there. But because of the nature of angles and going back and forth, there's always more than one way to get to a point. In fact, if we'd gone backwards, that'd be -pi over 6. And out 1. You know how many different ways there are to describe point B? What's that? If you remember that you can go more than once around, it means there's an infinite number of ways to describe point B. Because you could go 2 pi plus 11 pi over 6. Or you could go 2 pi plus 2 pi plus 11 pi over 6. You can spin around however many times you want. And so that means the number of possibilities for naming point B are literally infinite. Now, hopefully everyone's going to pick something that's, one of these. Probably most people would pick this one if they were given the choice. But when I give you coordinates, there's different ways to land at the same spot. Let's see, we got plenty of room. Let's switch to the next graph, just so we don't get confused. (3, -4 pi over 3). So this time the negative's on the angle. What does that mean in terms of rotation? Some hand motions. It means go backwards. So instead of rotating up, we're going to rotate down, and we're not going to rotate backwards to get to 4 pi over 3. 4 pi over 3 is the amount of angle we need to rotate through. So if I rotate backwards 4 pi over 3, what angle do I land at? 2 pi over 3. So I go backwards 4 pi over 3, I land at 2 pi over 3. And then I go out 3. So 1, 2, 3. Now, you may remember some people really don't like negative angles. Do you remember how to get a coterminal angle if you want to avoid the negative thing? I can add 2 pi and I'll land at the same spot. So if you're having trouble with the negatives and you can't figure out, well, how far do I need to go? Well, add 2 pi. And of course, add fractions correctly, though. And you end up at 2 pi over 3. So most of you won't need to do that, but if you hit one and for some reason your brain locks and you can't figure out, well, how far backwards is that? Well, add 2 pi and just go the other way to get there. Let's try a point D. -5, -7 pi over 4. So that's basically as complicated as we can make it. It has 2 negatives on there. See if you can graph that one. All right, so -7 pi over 4, backwards, 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 almost all the way around to pi over 4. So there's -7 pi over 4. But then -5 means go backwards. So go backwards 5. 1, 2, 3, 4, 5. For point D. While we're there, why don't you name point D 2 different ways? See if you can come up with 2 more ways to name point D. Okay, so there's 2 more ways to name that point. To me, the most straightforward way is to use the positive angle and the positive radius. So rotate 5 pi over 4, go out 5. Like that to me would be the easiest way to do it. Then if you wanted to get complicated, you could say, well, I'm going to go backwards 3 pi over 4, out 5. And I suppose if you really wanted to be complicated, you could go up pi over 4, but then backwards 5. So again, that's 4 ways to do it, but there's a million other ways to do it as well. All right, you feel comfortable graphing points? All right, back to the notes then. Let's talk a little bit, and we've kind of already done this, so we sort of built this in. Renaming points. We've done this a little bit already. So let's take the point 3, -4 pi over 3. And I want you to get used to seeing this table that we're going to lay out because you're going to see it several times. So I want you to rename the point with the positive positive, with the positive negative, with the negative positive, and with the negative negative. Well, the one they gave us is a positive radius and negative angle. So we already have that one. Now we need to come up with other ways to do that. What do you think is the first thing I should do to make this work? I would plot the point. There are ways to do it around it, and you're right, adding 2 pi would give you the same angle, so that's one way to go. I think I would just plot the point and see what it looks like, and then go from there. So -4 pi over 3 would be at 2 pi over 3. And then we go out. Oh, we already did this point. It was point C. Oh, well, I'll graph it again. So 2 pi over 3 and then out 1, 2, 3. So the first easiest other way to name the point is with positive positive. So we rotate 2 pi over 3 and go out 3. Sydney, what you said when I asked that question a minute ago was add 2 pi. That would work. And so just be careful, because there's ways to sort of memorize the way to do this, and there's ways to look at the picture and figure it out. To me, looking at the picture and figuring out would be the way to go. All right, let's come up with a way that is a negative radius and a positive angle. Well, the negative radius would have to be -3. So let's see how to think backwards. So that means I want to land, if I want to use a backwards 3, I want to land down here at 5 pi over 3. So we'll rotate to 5 pi over 3 and then go backwards 3. And then negative, well, it's got to be -3, which means I want to land on this angle, the 5 pi over 3, but I don't want to get there the 5 pi over 3 way. I don't want to get there the positive route. I want to get there the negative route. So what's this angle? How far is that opening? So we go backwards, -pi over 3. So renaming points, again, you can memorize, we'll add 2 pi, add pi, subtract pi. Don't do any of that. I think it's better to just plot the point and figure out the ways to get there. All right, last Roman numeral. We want to convert polar and rectangular. So we want to be able to go back and forth between the two systems. So first, let's go polar to rectangular. In fact, let's use that same point, 3, 2 pi over 3. We want to turn that into an xy coordinate. So not an r and a theta, but an x and a y. Well, x is r cosine theta, y is r sine theta. That should look kind of familiar, because cosine goes with x, sine goes with y, and so that continues still. So x is 3 cosine 2 pi over 3. Let's see, cosine of 2 pi over 3 would be -1/2. Right, we really need to know our unit circle, otherwise it just takes too long. Y is 3 sine 2 pi over 3. 3 sine 2 pi over 3. Sine of 2 pi over 3. Let's see, that'd be that height. That'd be root 3 over 2. So 3 root 3 over 2. And then we want to write that as a point. So x comma y, -3/2, comma 3 root 3 over 2. Which means, I don't know if we could graph both of these on the same. If we graph both these points, they'd land at the same spot. It's hard to overlay the graph. So that would be -1/2. That's an easy one. 3 root 3 over 2, I would just type it in the calculator, and that would be 2.6. So if I wanted to, I don't have that point anywhere. So two ways to describe that point. One would be the polar way, one would be the rectangular way. Just going back and forth between the two. That one you just kind of just have to memorize. You got to know, I mean, it's open note test, you don't have to memorize it, but that you got to know. The rectangular to polar you can figure out. So let's take the point 2 root 3 comma negative 2 and turn that into an r theta. So let's draw a picture. So 2 root 3, that's, if I want to graph that, that's 3.4-ish. Root 3 negative 2. Right? That's the rectangular coordinates. And we want to know the r and the theta. So what do you think? How can we figure out what r is if we know those two lengths? We're going to use that in a minute, rise over run, but that sounds like a slope thing. This is a right triangle, so somebody said it, I think. Pythagorean theorem. So r squared is equal to x squared plus y squared. Let's see if this works out to give us something nice. Square root of, let's see, that'd be 4 times 3 is 12. If we square negative 2, we get 4. So that would just be 4. Kind of a rigged problem to work out to give us a nice r. All right, to find that angle, theta, you mentioned rise over run, and what we did on Friday was rise over run is slope, but it's also the tangent of the angle. So if we do inverse tangent of rise over run, so there's the ways to get to r and theta. So inverse tangent of opposite, or y, over adjacent, running out of space, negative 1 over root 3. That looks like a unit circle thing, especially if I fix it. Negative root 3 over 3. Or, if you drew your picture well from the get-go, you might say, well, that looks like a, especially once you realized it was a unit circle thing, that looks like negative pi over 6. Root 3 over 3, that's a pi over 6. So negative pi over 6. So my r theta would be 4 comma negative pi over 6. Now, sometimes we get picky about, we would rather use negative pi over 6 than 11 pi over 6. But this time it doesn't matter because they both land at the same spot. So if you look at that and your brain thinks, well, that's 11 pi over 6, that's okay because that's at the same point. It's okay to do that. All right, your assignment today is worksheet 2. It's just the front page. There's not even a back to it. First 4 are plot the point, so that should be pretty straightforward. Number 5 looks complicated, but it's really just plot the points. So come up with some points and then plot them. Maybe we should do one of those together. So if r is 3 sine theta, and theta is pi over 4. And let's see, sine of pi over 4, that's the one in the middle, that'd be root 2 over 2. So there's one answer is 3 root 2 over 2. I mean, that's not wrong, it's just where in the world is 3 root 2 over 2? So it's okay to use a calculator and say, you know what, I need to get a decimal for that. 3 root 2 divided by 2 is 2.1. So I didn't do this really well, but because I don't know how far 3 root 2 over 2 is. So I get a calculator, rotate pi over 4 and out 2.1. And you know, you've graphed with decimals before. You just kind of eyeball and hope that the 0.1 is close enough. I'm not going to be looking close enough to take off, as long as it's 0.1 and not 0.8. Third set, we did something like this. I would probably graph that point first and then figure out the other ways to get there. And then there's from polar to rectangular. And then the last set is vice versa, from rectangular to polar. All right, I'll post answers to this. I'll post all of them so you can check them all. And again, we're 2/3 of the way through the unit now, so we're getting close.